Radian measure of special angles. We're going to recall special triangles that we have seen before. The 45, 45, 90 triangle, which is 45 and 45 degrees, and this is the right angle. And the 30, 60, 90 triangle, which is 30, 60, and 90 degrees. And we also use these lengths, 1, 1, and the hypotenuse is root 2. And for the 30, 60, 90 triangle, we have the 1 root 3 for the two legs, and the hypotenuse is 2 units. And we use this to kind of know what the sine, cosine, and tangent ratios are for the primary trig ratios for the angles 30, 45, 60, and 90. So if we were to use our special triangle to find the sine, cosine, and tangent of 0, 30, 45, 60, and 90 degrees. Sine 0 is 0, cos 0 is 1. Tan is sine divided by cosine, so it's 0 divided by 1, which is 0. Sine of 30, while looking at this special triangle, sine of 30 is opposite over hypotenuse, which is 1/2. Cos of 30 is adjacent over hypotenuse, which is root 3 over 2. Tan of 30 is opposite over adjacent, which is 1 over root 3. Sine of 45, we can tell looking here, 45 degrees, opposite is 1, hypotenuse is root 2, so it's 1 over root 2. Cosine of 45 is adjacent, which is 1 divided by root 2, 1 over root 2. And tangent of 45 is sine 45 divided by cosine 45, which is 1. Or looking here, we can see opposite over adjacent is 1 over 1, which is 1. Sine of 60, we're looking in this triangle, opposite over hypotenuse is root 3 over 2. Cosine of 60 is 1 over 2. And tan of 60 is root 3 over 1, which is root 3. Sine 90 is 1. Cos 90 is 0. Tan 90 is sine 90 divided by cos 90, 1 divided by 0, which is undefined. Okay, and I kind of memorize these ratios. They are the exact ratios. And how I remember that is sine, when you go from 0 to 90, is increasing, right? From 0 to 0.5 to 1 over root 2 to root 3 over 2 and finally to 1. And you have the opposite for cosine as it goes from 0 to 90. It decreases from 1 to 0. And tan also increases, 0, 1 over root 2, 1, and then root 3, and tan of 90 is undefined. We have to also get familiar with the radian measures for the angles. So this is 0 radians. 30 degrees is pi divided by 6. 45 degrees is pi over 4. 60 is pi over 3. And 90 is pi over 2. Okay, so if you think about it as pi as 180, 180 divided by 60 is 30. 180 divided into 4 is 45 degrees. 180 divided by 3 is 60. And 180 divided by 2 is 90. So for the special angles in radians, 30 degrees is pi divided by 6. 45 is called pi divided by 4. 60 is pi divided by 3. And 90 is pi divided by 2. So if you wanted to find the exact values, when it says exact means you don't use any calculator, because if you use a calculator, it'll give you the answer to 4 decimal places. You round it to 4 decimal places. We don't want that. We want the exact values for sine, cosine, and tangent of these angles. So sine of pi over 6. Pi over 6 is 30. So sine 30, well, we can use the special triangle to help us. If we have the special triangle, this is 30, this is 60, this is 90, this is 1, root 3, and this is 2, right? And we want to kind of familiarize ourselves with the angles as given in radian measure. So this will be called pi over 6. This angle will be called pi over 3, right? 30, 60, 90. And so sine of pi over 6 is 1 over 2. And cosine of pi over 6 is adjacent side over hypotenuse, which is root 3 over 2. And tangent of pi over 6 is opposite over adjacent. Opposite over adjacent is 1 over root 3. Pi over 3 is a 60-degree angle that's here. Sine of pi over 3 is opposite side over hypotenuse, which is root 3 over 2. Cosine of pi over 3, well, pi over 3's adjacent side is 1 divided by hypotenuse, which is 2. And tan of pi over 3 is opposite over adjacent, so it's root 3 over 1, which is root 3. And then we find the trig ratios, the primary trig ratios for pi over 4. So sine pi over 4, cosine pi over 4, and tangent pi over 4. Sine pi over 4, we can use a special triangle, which is pi over 4. This also is pi over 4, and this is 90, and this is, what are the measures of this? Is 1, this is also 1, this is root 2, right? So sine of pi over 4 is opposite side over hypotenuse, which is 1 over root 2. Cosine is adjacent over hypotenuse, which is also 1 over root 2. And tangent is opposite over adjacent, which is 1 over 1, which is 1. So we have to be comfortable with giving the primary trig ratios of angles given to us in radians and be able to draw these special triangles to kind of get those answers. We also need to look at quadrant angles, angles that are multiples of 90 degrees and have a terminal arm which lie on either the x-axis or the y-axis. So if you start looking at how the angles can be labeled with regard to an xy coordinate system, you can have the angle which starts with one arm of the angle is here. So this is one side of this angle, and the other arm is this arm here, which is called the terminal arm. So between the initial arm and the terminal arm is the angle that's formed, which is theta. Okay, so if I move the terminal arm here, then my theta will go from here in the anti-clockwise direction from the initial arm till here. That's my angle. If my terminal arm is here, then my angle is from the initial arm all the way to where it is, and so on and so forth. We also have these points in the unit circle. So you can see a unit circle is a circle where the radius is equal to 1 unit in length. So this length from here to here is 1. And the coordinates of that point are 1, 0. This point is 0, 1. This point is negative 1, 0. And the coordinates of this point are 0, negative 1. If you take a point in this triangle, let's call this point P, and its radius is r, so this length or the hypotenuse of this right angle is r, and let's call this vertical length from here to here y, and this length from here to here as x. So the coordinates of point P, its x coordinate will be x and its y coordinate will be y, but we can also define that in terms of the trig ratios. So if you look at this triangle, the sine of theta is opposite side over hypotenuse. It's y over r. So therefore y, if you cross multiply here y, you get y is equal to r sine theta. R is 1 for the unit circle, radius is 1, so it's 1 times sine theta, which is sine theta. Similarly, if you look at the cosine of theta with respect to this triangle, cosine is adjacent side over hypotenuse, so it's x over 1. So therefore, I just wrote hypotenuse instead of r, I wrote it. Okay, let's write r here. So if you cross multiply x, we get is equal to r cos theta. R is equal to 1, so x is equal to just cos theta. So this point P can be rewritten as, instead of x comma y, in place of x I'm going to write cos theta, and in place of y I'm going to write sine theta. So for any point on the unit circle, the value of the x coordinate will always be cosine of the angle that's formed there. And the value of the y coordinate will always be the sine of the angle there. So what's useful is if I wanted to find sine of this angle, which is when the terminal arm is on top of the initial arm, the angle is 0 for theta. So cos 0 is 1, sine 0 is 0. If the terminal arm moves all the way to here, creating a 90-degree angle, cos 90 is 0, sine 90 is 1. Okay. If you move the terminal arm all the way to here, so the angle theta is like, 180 degrees or pi, cos pi is -1, sine pi is 0. And if we move the terminal arm all the way here to create this angle from here to here, which is 270 degrees or 3 pi over 2, cosine of that angle, 270 is 0, and sine of that angle is -1. Okay? So we're trying to get familiar with degrees and radians. 0 degrees is 0 radians. 90 degrees is pi divided by 2. So it's like 180 divided by 2. Pi is 180. 180 is pi, right? 270 degrees, which is from here all the way to here, is 3 pi over 2. And one entire revolution there, which is 360 degrees, is 2 pi. So pi is from here to here, 2 pi is all the way. Okay. So if you had to find the exact value means we're not going to find the answer using a calculator, we're going to use unit circle. And I'm going to write the measures here. This is 0 degrees or 0 radians and also 2 pi radians here. This is pi by 2, which is 90. This is pi, which is 180. This is 3 pi over 2, which is 270. Okay, so I want to get familiar with those ways of writing the angle instead of degrees. So each point, its x coordinate is cosine of theta and its y coordinate is sine theta. Okay, and this point here, its coordinates are 0, 1. This one here, it's 1, 0. Here it is -1, 0. And here it is 0, -1. So sine of pi by 2 is the angle here. So this is cosine of pi over 2. And the 1 is sine pi over 2. So sine pi over 2 is 1. Okay, sine pi, well, this is cosine pi, this is sine pi, which is 0. Cosine 3 pi over 2, so that's 0, as you can see here. Secant 2 pi. Secant is the reciprocal of cos theta, so it's written as 1 over cos 2 pi. So first let me find cos 2 pi. So 2 pi is right here, and this is cos of 2 pi, which is 1. So 1 over 1, which is 1. Tan of 7 pi over 2. So 7 pi over 2, well, this is 1 pi over 2. When you go from here to here is 1 pi over 2. 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. So 7 pi over 2 ends up here, which will be the same as 3 pi over 2. So if I wanted to find the tan of 7 pi over 2, it will be the same as the tan of 3 pi over 2, because it ends up being the same angle. It ends up right here, 3 pi over 2. And tan, as we know, is the ratio of sine over cos. So tan of an angle is the ratio of the sine of that angle, sine of 3 pi over 2 divided by cosine of 3 pi over 2. So what is sine of 3 pi over 2? Sine of 3 pi over 2 is this number, -1. Cosine of 3 pi over 2 is 0. So I'm dividing a number by 0, so this is an undefined ratio. Find the exact value of each ratio. So this time I'm being given the questions in degrees, not in radians. And that's for the first 3. and the next 3 are in radians. Okay, so I need to be comfortable with both. How do I find the cosine of 210? So the way we do that is we try to find the related acute angle to 210. Okay, so I'm just going to draw my xy plane here. Where would 210 be? This is 0 degrees. This is 90. This is 180. This is 270. So 210 is between 180 and 270. So it's going to be somewhere here. So it's going to be an angle that is in the third quadrant. And we have the cast rule, right? CAST rule, which tells us that in the first quadrant, which is here, all the 3 trig ratios are positive. The second quadrant, only sine is positive for S. Third quadrant, only tan is positive. And in the last quadrant here, only cosine ratios are positive. So 210 lies in the third quadrant where only tan is positive. So now my answer is going to be a negative because I'm asked cos of 210. But what is the angle, the acute angle that is similar to 210? So for that, if I were to extend this angle in the first quadrant, what would this angle be? Okay, so from here to here, it's 180 plus this extra angle. This extra angle here is going to be the same as this angle here. So if I do 210 minus 180, okay, I'll get this angle here. So 210 minus 180 is 30 degrees. So the related acute angle is 30 degrees. So cos of 210 will be the same as cos of 30 degrees. But because 210 is in the third quadrant where tan is the only ratio that's negative, my answer will be negative. So it'll be negative of cos 30. Cos 30 is root 3 over 2. So it's negative root 3 over 2. Okay, so what are some of the steps I took in arriving at the answer? I first kind of located which quadrant it is in. I then found out which is the acute angle related to it. Found the trig ratio of that acute angle because I know all the special angles, 30, 0, 30, 45, 60, and 90. I know all their trig ratios. So once it's related to those, I can have the answer. And I want exact answer, so not using the calculator. And then I also have to decide if the answer is positive or negative, depending on where the terminal arm ends. Okay? Cosecant 330. So I'm going to draw the grid again. This one was for part A, by the way. I'm going to draw another grid here for 330. Where's 330? 330 is, this is 270 and this, so it's going to be somewhere in the fourth quadrant, right? So my angle is from here all the way to here, 330 degrees. So what is the related acute angle that relates to this angle? So this angle here will be the same as this angle here. Okay, so if I do 360 minus 330, I get 30 degrees. So the related acute angle here is 30 degrees. So cosecant 330 will have the same numerical measure as 30 degrees. But I also notice that cosecant is a secondary trig ratio. So I'm going to rewrite this in terms of its primary ratio. Cosecant is a reciprocal of sine, so it's 1 divided by sine 330 degrees. And sine 330 degrees is the same as sine of 30 degrees. But 330 is in the third quadrant where sine is negative. So my answer will be negative of whatever sine 30 is. So it's 1 divided by negative 1/2, which I don't have space here, so I'm just going to write it here, is negative 2. Okay. Tan 225. Let's place it. Where is 225 going to be? Well, 0, 90, 180, 270. So it's going to be here. Somewhere here. And that's the angle 225 degrees. What's the related acute angle for this it's going to be, 180 plus some amount of angle. So 225 minus 180 will give me the related acute angle, which is 45 degrees. So tan of 225 will be the same numerically as tan of 45. And it ends up in the terminal arm of this 225 ends up in the third quadrant where tan is positive, so it'll be positive. Tan of 45 is 1, so the answer is plus 1. Okay, now I have to find sine of 5 pi over 4. So it's no longer in degrees. So one way to work around that is to kind of figure out where that actually is. So we have 0. Pi over 4 is 45 degrees, right? So this would be the first pi over 4. This will be 2 pi over 4 or pi over 2, right? And then this will be 3 pi over 4. This will be 4 pi over 4, which is same as pi, and this is 5 pi over 4. Okay, so I'm just making increments of pi over 4 or 45 degrees. So this angle sine 5 pi over 4, pi over 4 is an angle that starts here and ends here, where it's in the third quadrant where only tan is positive. I'm asked to find sine of it, so my answer is going to be negative. So sine of 5 pi over 4 will be a negative, and it'll be the same numerically as the related acute angle. The related acute angle is pi over 4, which is 45 degrees, right? So 45 degrees. So what is sine of 45 degrees? Sine of 45 is 1 over root 2. So it's negative 1 over root 2. Sometimes people leave this answer without a square root in the denominator. So equivalent answer for this is negative root 2 over 2. And the way you get that is you multiply both the numerator and denominator by root 2 over root 2. So when you multiply and divide by the same number, there's no difference, right? So 1 times root 2 is root 2, 2 times root 2 is 2. And both of these numbers mean the same thing. You can leave it in either form. Cosine of 11 pi over 6. I'm going to do that in a new page. Cosine of 11 pi over 6. Where is that now? Let me draw my grid and figure out where that is. Okay, so pi over 6 is 180 divided by 6, like 30. So that's the related acute angle, 30. So this is my 0. This is my, 30, right? And then this is my 2 times 30. This is my 3 times 30. And then 4 times 30, 5 times 30. I'm just going to figure out where 11 ends up. So 1, 2, 3, 4 times 30, 5 times 30, 6 times 30, 7 times 30, 8 times 30, 9 times 30, 10 times 30, 11 times 30. Okay, so 11 pi over 6 is the angle that starts here and ends here. So it's in the third quadrant where cosine is positive. If you remember the CAST rule, C-A-S-T, this angle, 11 pi over 6, ends in the third quadrant. So our answer is going to be positive. But what is it numerically going to be same as? It'll be the same as cosine of pi over 6, because that's the related acute angle, this angle here. Pi over 6, as you know, is 30. Cosine of 30 is root 3 over 2. So the answer is plus root 3 over 2. The last one we have is cot of 2 pi over 3. So where is that in my grid? This is pi over 3 is 180 divided by 3, which is 60. Okay, so that's my 0. This is my pi over 3. 60 plus 60 is 120. So this is my, so 60 plus 60. So 1 pi over 3, and then you add another 60, you end up with 2 pi over 3. So 2 pi over 3 is the angle between this initial arm and terminal arm here. So it's an angle that is in the second quadrant where, sine is positive. Okay, so only sine ratios will be positive in this. The related acute angle is pi over 3. Okay, cot is a secondary trig ratio, so you're going to write this as the reciprocal of tan, 2 pi over 3. Tan is negative in this quadrant where 2 pi 3 ends up, so it's going to be a negative answer. And it's going to be related to the acute angle. The acute angle related to pi over 3 is pi over 3. So it's 1 over negative of tan 60, which is root 3. Okay, so it's negative 1 over root 3. And if you want to rationalize or remove the radical in the denominator, you multiply and divide the denominator and numerator by root 3, and you get negative root 3 over 3. So this answer or this answer both are fine. Okay, point P, negative 5, negative 12 is on the terminal arm of theta in standard position. Find the 3 primary trig ratios for theta. So we need to locate that point. Let's draw our grid. And where is negative 5, negative 12? So let's say this is negative 5 and this is negative 12. The point will be somewhere here, right? Negative and negative. This is our P. So our angle is here. So our angle is from here to here, which ends in the third quadrant, where tan is positive, right? This is CAST. So in this third quadrant, only tan ratios are positive. Sine and cosine are negative. I'm going to find the 3 primary trig ratios for theta. How are we going to know what the trig ratios are? Let's complete this triangle. Let me just draw a straight line like this. And I draw this so I can create a right angle triangle here, where this length from here to here is negative 5. This length from here to here is negative 12, right? And this is the hypotenuse. So I'm going to find the hypotenuse or the radius of this. The hypotenuse is the square root of negative 12 squared plus negative 5 squared. That works out to root of 169, which is equal to 13. So I know this length is now 13. Okay. The primary trig ratios, let me just create some space here. Maybe write it over here. Sine of theta, which is the angle from here to here, will be the same as, so let's say this is my angle theta. Sine is opposite over hypotenuse, so it's negative 12 over 13. Cosine of theta is adjacent side, negative 5 over 13. And tan of theta will be opposite over adjacent, which is negative 12 divided by negative 5, or tan theta equals 12 over 5. So those are the 3 trig ratios for that point. Find angle theta to the nearest degree. So if I just use any of these 3 ratios, let's use the sine ratio. If sine theta let's use the tan one, it's positive. So tan theta is 12 over 5. So angle theta is tan inverse of 12 over 5. At this point, you can go to your calculator and I'll give you the answer as negative 67.38. You know, we can just say that our angle is positive. In this case, the acute angle, the related acute angle to this is the positive of this 67.3 to the nearest degree, so just 67 degrees. 67 degrees. So what is the actual angle? The actual angle is from here all the way till here. It's not 67 degrees. It's far more than 67. So you have to add a 180 to it. Okay, so the actual angle is 180 plus 67 degrees, which is 247 degrees. Okay, so that is the angle to the nearest degree. If you wanted to find that answer in radians to the nearest hundredth, what would you do? So we would say like theta is equal to tan inverse of 12 over 5, like we did. And we have to set our calculator to radians mode. So set calculator to radians mode. Otherwise, we'll get the same answer we got in the previous part. And so we get theta equals 1.18. And again, this is the related acute angle. Okay, so we want to find, this is the angle here. We want to find the entire angle. So we've got to add a 2 pi to it, right? So therefore, actual angle is 2 pi plus 1.18, or sorry, not 2 pi, pi, just 180. So 3.14 plus 1.18, which is approximately, to 2 decimal places, 4.32 in radians. You can write radians here.